We have done for the wire, the seat, and we have done dipole.
No, sir.
We will discuss the case of dipole. Today we will discuss about dipole. So dipole axial case, equatorial case, we have not done, right?
No, sir.
Right.
Yes, sir.
What are the portion we have covered?
Sir, last we did was flux, sir.
Last class, what was the thing discussed?
So we did sums on flux.
The notes I have sent, right? Check the note and see that what are the portions discussed in the last classes, last two class. So what are the things discussed in the last two class?
Sir, we did sums on flux and field.
Flux, right?
Yeah.
So that field and Coulomb's law was discussed.
Yeah, we did that.
Dipole is not discussed yet.
Dipole we didn't do, sir.
So dipole means two poles, one positive and another negative. Plus Q and minus Q charges separated by a small distance, let's say 2a. We call them dipoles.
Yes, sir.
So dipoles are having two poles, let's say plus Q and minus Q. These charges are separated by a distance 2a. Okay. They are called dipoles. The direction of the dipole is, by convention, it's minus Q to plus Q. Remember this, and we denote with pk. The direction of the dipole is from minus Q to plus Q, and we denote it with symbol pk. Now, these dipoles are basically, or you can say, inside in an atom, nucleus is at the center, having positive charge, let's say plus Q charge, and electrons are revolving in around the nucleus, having total minus Q charge, same amount of charge. Now, suppose any positive or some atom will come which has more electron affinity or electron they can pull the electrons towards them. So what will happen, or it is positively charged. So what will happen, these electrons, all the electrons will be accumulated at one place. They will come one side and this positive nucleus will be pushed. So a small gap will be created in between. They create a generally dipole. So dipole are very small distance between the charges, that is maybe in the order of micro or angstrom. In that order, the difference between the two charges, equal amount. This would be minus q plus q. Let's say this is 10 microcoulomb charge and minus 10 microcoulomb, this would be plus 10 microcoulomb only. So same amount, charge amount should be same and distance should be very small, maybe in the order of micro or angstrom. They form a dipole. They form a dipole. So we'll discuss two cases for dipole. What we'll discuss? We'll find out the electric field due to dipole.
Yes, sir.
Calculate two cases. For two cases, first case is field or electric field on the axis. Field on the axis of the dipole. On the axis of the dipole means, let's say two charges are there, that is forming a dipole, let's say minus q and plus q, or plus q the minus q. Distance between them 2a. Now what is the axis of the dipole? This is the axis of the dipole. This is the axis of the dipole. Another case which we will discuss in next part, that is a field on the equatorial plane. Field on the equatorial plane. So what is the field on the equatorial plane? Field on the equatorial plane.
Not sure, sir.
Equatorial means it's perpendicular. Suppose this is the two charges, minus q plus q. They are forming a dipole and this is perpendicular bisector. Right? This is the perpendicular bisector. So on this equatorial, this is the equatorial, that any point on this axis will find out the electric field. We'll find out the point on the equatorial. So two cases we'll find. One is called axis of the dipole, and another is equator of the dipole. So two cases we'll find. The first one is electric field on the axis of the dipole. So let's say, or let's take a point P on the axis of the dipole. Let's take a point P on the axis of the dipole. So we'll find out electric field here at point P. Now let's say the center of the dipole is at O, and this point P from the center O is at a distance, let's say R. Let's say the point P, which is on the axis, is at a distance R from the center of the dipole. So can you say now, what will be this distance from plus Q to P? What will be this distance plus Q to P? What we can write? From midpoint, this distance will be A, this distance will be A. Look at the diagram carefully and tell me So what will be the distance between plus Q to P in terms of R and A? What will be the distance between what will be the distance what will be the distance okay, so what will be the distance? Can I write R minus A, this distance P?
Yes, sir.
Because from the center to the point P, it is R, and from O to this plus Q, this is A. So what will be the distance from plus Q to P? R minus A. Are you getting?
Yes, sir.
Now, what is the formula for? What is the formula for your electric field? What is the formula for electric field?
Sir, could you repeat your voice, bro?
Formula for electric field.
Sir, hello.
What is the formula for the electric field?
Sir, force by charge, right?
Force electric field force by
Sir,
charge F by Q,
yes,
or you
sir.
can write electric field is 1 by 4 pi epsilon naught Q by R square. This is the electric field. Okay.
Yes, sir.
Electric field. Now, due to plus Q charge, what will be the direction of the electric field? due to plus q charge, what will be the direction of the electric field? The direction of the electric field will be to the left because plus charge, the fields are lines are away from the charge. If this is a positive charge, the field lines will be away from the charge. This is the electric field lines by convention. Direction of the field lines. This is by convention, the direction of the field lines. Clear? So, due to plus q charge, the electric field lines will be E plus Q. This is to the left side. And minus Q, the field lines will be towards. So, for minus Q charge, the field lines will be towards. So, this is E minus Q. So, you can see that both the field are opposite direction. So, you can subtract them to get the net field on the P. For example, suppose this is a box. If you are applying 5 Newton force to the right side and 2 Newton force to the left side, if I'll ask, what is the net force on the box? What is the net force on the box?
It'll be 3 Newton to the left. I mean, to the right.
3 Newton to the right.
Yeah.
Okay. So this will be the 3 Newton to the right. So this is the net force. Similarly, because vector we can find the net one, here also we can find the net field. We can find the net field.
Sir.
So what will be net field? What will be E plus Q and E minus Q? Let us find. What is E plus Q?
E plus
E plus Q will be 1 by 4 pi epsilon naught. Charge is Q.
Q1, Q2
Distance
by
is
R square.
distance is plus Q to P distance. That is R minus A. So R minus A whole square. What will be E minus Q? This due to this minus charge. What is the distance? From P to this point O, it is R, and O2 minus Q is A. So what will be the total distance from P to A to minus Q? Can I write R plus A?
Yes, sir.
So E minus Q will be 1 by magnitude I am writing 1 plus 4 1 by 4 pi epsilon naught Q by R plus A whole square. So what is the net electric field? Just we have to. What is the net electric field? Net electric field is, we'll subtract it. E plus Q, E at point P equal to E plus Q, E plus Q minus E minus Q, because they are in opposite direction, so magnitude will be subtracted. Your net field will be minus. So what the common I can take, this are magnitude I have taken, so common will be Q by 4 pi epsilon naught, and this will be Q by R minus A whole square. Q common 1 minus 1 by R minus A whole square minus Q by Q the common R plus A whole square. Are you getting?
Yes, sir.
This is the total field. This is the total field. What you are getting? Qy 4 pi epsilon naught 1 minus 1 upon r minus a square minus 1 by r plus a square. So what you are getting finally, if you simplify, so total electric field E at point P equal to, you are getting Q by 4 pi epsilon naught 1 by r minus a square minus 1 by r plus a square. So what will be this? Q upon 4 pi epsilon naught. If we simplify, what will be LCM? R minus a square minus 1 upon r plus minus 1 upon r. So if you simplify, what you will get? Can I write this? Can I write this? What I can write? R plus r minus when I write this, r minus a whole square, okay, r minus a whole square into r plus a whole square. So it will be r plus a whole square minus r minus a whole square. Can I write this? Any confusion in this? Can I write this?
Yes, sir. Yes, sir.
How it is done? Just we have taken LCM. Can you see?
Yes, sir.
LCM. Okay. And multiplied. You can write in your notebook. Okay. You
Yes,
see what
sir.
in the denominator r minus a whole square and r plus a whole square is there. So what will be LCM? LCM will be r minus a whole square into r minus a into r plus a whole square.
Yes, sir.
So r minus a square, if you divide, it will be r plus a square in the numerator minus, if you divide r plus a square, it's like 1 by x square minus 1 by y square. How do you do that? LCM will become x square y square, and if you divide x square, you will get y square minus, if you divide y square, you will get x square. This is how you do, right? The same thing is done. R minus a whole square, r plus a whole square, it's taken, multiplied, and in the LCM. Okay. Then it's simplified. The fractional addition just. Clear?
Yes, sir.
So now if I'll simplify further, what I'll get? Q upon 4 pi epsilon naught. In the numerator, r plus a whole square minus r minus a whole square. What can I write for that? It's like a plus b whole square minus a minus b whole square. What is a plus b whole square minus a minus b whole square?
Sir, what could you repeat?
Numerator, what is there? R plus a whole square minus a r minus b whole square. So what will be
Yes,
the
sir.
numerator?
R square plus a square plus 2ra minus r square plus a square minus 2ra.
Cancel it out. What will be cancelled? And what will be
Sir, there'll only be, it'll be, I think, 4ra, sir.
4 ra. It will be 4 ra. A plus b whole square. It's like a plus b whole square minus a minus b whole square, right? In the form a plus b
Yes,
whole
sir.
square minus a minus b whole square form. So it's 4ab. So it will be 4ra. And in the denominator, can you see that a plus b and a minus b form? It's in the form of a plus b and a minus b. Can you see the
Yes,
denominator?
sir.
So the denominator is in, we can write r plus a r minus a whole square. Can I write like this? And this is q by 4 pi epsilon naught 4ra by a plus b into a minus b. What I can write for that? A plus b and a minus b. What I can write for a plus b and a minus b?
You can write a square minus b square.
A square minus b square, very good. So in the denominator, it will be my r square minus a square whole square. Fine.
Yes, sir.
Inside bracket a plus b into a minus b is there. So a square minus b square, and outside the bracket another square is there. So square is there. Clear. Now we'll use some. This is our electric field on the axis actually. Okay. This is our electric field on the axis. But here we'll use some assumption and we'll simplify and get another terms. Another term for that. So what assumption we'll use here? We'll use another assumption. The assumption we'll take is that R is very greater than A, because our dipole, as I have told you, it's of plus q and minus q charge separated by a very small distance 2a. Okay. So on the axis we are finding out the electric field at a point P. So R is the distance from the midpoint to the point P. So this R is quite larger than this A, the dipole, the separation between the two charge or the length of the dipole. So it's very small h compared to R. It's very small h compared to R. So if
Yes, sir.
R is quite bigger than A, so if I'll subtract a small number, very small number from a bigger number, the result will be approximately the bigger number. What does that mean? Suppose if we'll subtract R square is 1000 minus A square is, let's say, 0.01. So what you will get the result? 999.09. Right? Not 09. Let's say 0.1. And this is 9. Okay. Clear?
Yes, sir.
Subtract, it's very close to 1000 only. 99.9 means it's very close. So that's why if a very small number, if we subtract from R square, the we can neglect basically the r square. R square is a square. If we'll subtract, not subtract, the value will not change very much. That's why we are subtracting. We are neglecting it. So you will write that as r is greater than a, we are neglecting a square. So what is the final expression we are getting? That field at a point P on the axis is q by 2 pi epsilon naught 4 4 pi epsilon naught 4 ra by r to the power 4. Now r is there numerator, r to the power 4 will cancel, r cube. So finally we are getting what we are getting. The final expression we are getting will be electric field at a point due to a charge due to a dipole of distance 2a on the point of the axis r distance on the axis from the center r. So what we are getting, electric field at the point P on the axis is 4qa by 4 pi epsilon naught r to the power 3. This is what we got the electric field. And what is the electric field direction? Because you see E plus Q will be bigger than E minus Q, because E minus Q is farther. E is more distance than E plus Q for point P. That's why E plus Q will be greater than E minus Q. That's why the direction of the field will be along E plus Q. The direction of the field will be along E plus Q. Why? Because E plus Q is bigger than E minus Q. Okay. E plus Q is bigger than E minus Q. So in vector form also we can write, this is the magnitude. If we write in vector form, because electric field is a vector, so we can write it in vector form. So if we write in vector form, so 4qa by 4 pi epsilon naught r cube, and it will be direction along E plus Q. That means it is along the direction of p cap. That is dipole vector direction, minus Q to plus Q, same direction. So we can write the direction is along p cap. So this is what your electric field at a point on the axis of the dipole. Electric field at a point on the axis of the dipole. So this derivation is very important for board exam, and its result is also important for the entrance exam also. So derivation practice once or two times for board exam.
Yes, sir.
This is an important derivation. And equatorial case also we'll discuss. Equatorial case we'll discuss in the next class. So when is your we have also not taken last week, so we'll take 1 or 2 extra class. Plus 2-3 classes we have not taken. So tomorrow is a holiday.
Yes, what, sir?
Tomorrow is a holiday.
Sir, tomorrow, no, sir. It's not.
Ambedkar Jayanti, there is no holiday for school.
No.
It's a national holiday, right?
No, sir, it's not exactly school. It's some other tuition class.
So in the morning you have other classes?
Morning, no, sir. What time?
For tomorrow?
Yes, sir. What time? Because if it's in the morning, I might be free according to the time.
Which time you are free?
Sir, anytime from 11 to like 2 p.m.